essential and the desirable properties. Out of this, we have completed essential properties and we have completed one desirable property, that is a fineness. So can any one of you will tell me which are the essential properties? At least name.
Sir, length, strength,
Yes.
uniformity, spinability.
Spinability.
Strength, uniformity.
Spinability, under spinability, again 2 points are there.
Flexibility and cohesiveness.
Yes.
Flexibility and ease.
Yes, good, correct. Okay, and then we have started with the fineness, and we have seen what the effect of the fineness which you are going to get means as the number of fibers are more in a given cross section area, we are going to get a more and more strength in that yarn. So that point we have seen. And whatever the fineness it is there, the fineness is expressed in terms of, for the cotton, we are expressing in terms of the micronear, whereas for wool and the other synthetic fiber, the fineness we are expressing in terms of denier or text it is there. Then next, we are talking regarding the resilience it is there. Now, resilience means it is a springing back or recovery of the fiber when it is released from the deformation. Means, for example, see, instead of fabric, just consider this is a fiber it is there. So what we are going to do, we are going to apply the pressure over here. We are going to apply the pressure over here, and after the certain time we are going to release this particular pressure, and we are going to check how much recovery it is there. Means suppose if this much is the thickness of that fiber, so how much recovery it is there after the whatever the compressive force when you are removing, whether we are going to get the 100% recovery, 80%, 90%, that we are checking it is there. So that property is nothing but the resilience property it is there. So resilience is just springing back or recovery of the fiber when it is released from a deformation. Deformation means when you are applying the load or whatever the compressive force it is there, this is called a deformation it is there. So the resistance to compression, flexion, or torsion varies from fiber to fiber. So whatever this resistance it is there, it completely depends on the fiber structure, means what type of the fiber it is there, how the molecular arrangement is there in this fiber. So all these points will govern regarding the resistance to the compression, or that is nothing but the resilience property. So this property will vary from fiber to fiber. Means for cotton fiber, resilience property is different. For wool it is different, for silk it is different, for synthetic fiber it is different. Again in a synthetic fiber, for nylon it is different, for wool it is different, for acrylic fiber it is different. Because now why this property we are going to get different from fiber to fiber. So for this we have to take into consideration the molecular structure or how these chains are arranged over there in a polymeric structure. Means whether they are arranged isotactic, syntactic, or atactic way. See, these points we will study, whatever the isotactic, syntactic, atactic, that you will study in a polymer science, or whether there is a bulky structure is there in a polymer chain, what type of the groups are present in a polymers. So all these things we have to take into consideration whenever you are talking regarding the resilience property. So some of these fibers have the natural tendency to return to their original position. So for example, if you take into consideration the wool fiber, nylon fiber is there. We got this, our acrylic fiber is there. So this fiber, they got a good tendency to come back to their original position it is there. So when the force is applied, an instant recovery from the creasing is required. So whenever we are applying the force, for example, suppose this force we are applying, see, this is our expectation that whenever we are applying the force it is there, it must come back to their original position. See, there are two things, resilience and elastic recovery, both are different. The resilience means related to the compression, means the we are applying. And elastic recovery means the load will be applied in this direction, to direction to the fiber axis. So that's the elastic recovery. So what are the wool fiber it is? The wool is outstanding with this respect by virtue of the natural characteristics. The cellulosic fiber may be modified in a such a manner so as to greatly improve this property. Now, whatever the wool fiber. So if you see the nature of the wool fiber, see wool fiber, there is a presence of the alpha keratin. It is there. Now, when you are extending it or when you are compressing it there, it will convert to the beta keratin. But again, it will come back to the alpha keratin. How, what is alpha, beta keratin? That I will tell you while studying the wool fiber. It is there. So because of this nature, see, because of this nature of the wool fiber, see the wool fiber got the great applications in the carpet industry. Now, every one of you are familiar with the carpets. It is there. For example, suppose if you see this is our base fabric, and these are the protruding fibers we are going to get in a carpets. The similar way we are using acrylic also, we are using nylon also, we are using polyester also. Now, talking regarding the natural, that is wool, why it is more popular in a carpet industry. Now, suppose if the carpet it is there, and that carpet we are manufactured by using the our cellulosic fibers, cotton. Now the cotton got the poor resilience property. So what will happen? Suppose if you are applying the pressure over here, suppose if you are walking it is there and we are given the pressure over here, and the carpet is made up of cotton, what will happen? Whatever the fibers in this portion it is there, it will get compressed. And they got a poor resilience property. What will happen? They will not come back to their original position. And whatever the look of the carpet, or after some time, instead of getting the carpet, will get a flat fabric over there. But that is not a requirement as far as the carpet is concerned. As far as the carpet is concerned, whatever the protruding fibers are there, they must come to their original position. That the requirement it is there. That's why we prefer to use wool for the carpet. It is there because of this property only. Because wool fiber got the outstanding outstanding resilience property. Because whenever you are applying the compressive force, again it will come back to their original position. Again, we can have the proper carpet over there. Now see how this property is helping. See, whenever we are designing any fabric, it is there, the selection of the fiber is also important over there. Now, as I told that one of the fabric that is a carpet, it is there. So now, do you think that are we going to select the cellulosic fiber for this purpose? Yes, any one of you? Are we going to select? No. Why? Because we
No.
know that whatever the cellulosic fibers it is there, they do not have good resilience property. That's why we cannot use the cellulosic fiber fabric, but we can use the wool fiber. Why? Because we know that whatever the wool fiber it is there, the wool fiber got a better resilience property it is there. Clear the point? So this springiness of the fiber or its mass resilience is highly desirable for the carpet wool. And because of the resilience of the fiber, yarn or the fabric hold their shape, they get fully, they do not wrinkle, and we are going to have the good resilience property in the fibers. It is there. So that the case it is there. And next, related to the capillarity and the porosity. So whenever you are talking regarding this property, now see again this is a one of the desirable property. Even if it is there, that is well and good. If it is not there, no problem, still we can use it, or we can do the modification into the fiber structure, or we can have this property over there. So porosity can be defined as the ratio of volume of the air contained within the boundaries of the material to that of the total volume of the solid plus air or void expressed as the percentage. Means how much percent porosity it is there. For example, suppose now this is a this is actually the fiber, coir fiber structure it is there. Now if you see this fiber, and there are small holes you can see. These holes are nothing but the porous nature it is there. Means if you see oh here, so porosity means it is a ratio of volume of air contained within the boundary. So whatever this air which is entrapped in this volume, to that of total volume, means total volume we have to take into consideration. Suppose now over here, the air, if you consider it is the volume of the air which is entrapped, 50 it is there. Just consider this is a 50%. It is 50 will get volume, 50 cc. It is a volume. It is the 50 cc will consider, and total volume that is a 100 cc it is there. So 50 by 100 into 100. So how much you will get? You will get a 50%. So that the 50% is the porosity of the given fiber. It is there. So likewise, we have to calculate the porosity of the fiber. Now, how this porosity will help us? So porosity facilitates the absorption of the moisture, liquid lubricant, dyes, or we can say the water, the moisture is there, water is there, liquid lubricant, whatever the dyes which are using for the dyeing purpose, whatever the oil, steam, by the fiber, so as to truly permit the fiber it is there. So whatever this, all the absorption of the moisture is there, chemicals are there, dyes, whatever we are using during the processing is happening through this voids only, or that is nothing but the porous structure. See, more is the porous structure, we are going to get a more and more absorption it is there. See, similar type of the porous structure we are going to get in a wool fiber also. So whatever the chemical absorption it is there, which is happening in a wool fiber, that happening it through this porous structure only. See, wool fiber can hold almost 1/3 of its weight of the moisture. See, when you are taking the 1 kg of the wool fiber, if you dip it in water, remove it, squeeze it, and after the squeezing, if you check the moisture of the water content, you will get 1.33 kg, means 1 kg of the wool fiber, and the remaining 33 we are going to get that is of the water it is there. Now why it got the good water holding capacity? Because of the porous structure. So whatever the water it is there, this water will go through these channels. So it will form this end to this end. So this is the cross section it is there. So throughout this fiber length, such a porous structure we are going to get. And if you compare the natural fiber or synthetic fiber, natural fibers we are going to get a good porous structure. That's why whatever the water absorption or the moisture absorption property of the natural fiber it is there, that is good. Even if you consider the cotton fiber, it is there, that also good. Wool, I already I told you it is good. Even if you see the banana fiber, it also got the porous structure, so that is also good. Flax fiber means all whatever the majority of our natural fiber it is there, they got the good porous structure over there. So the natural and the man-made fiber differs greatly in the respect of the porosity, which in turn affect their property of the fiber and consequently the processing of the fiber during the textile manufacturing. In general, natural fibers have higher porosity than the synthetic fiber. Okay. Now this is regarding the porosity. Now next regarding the capillarity. In physics, you have studied this term capillarity, capillary action. So you will tell me regarding the capillarity or the capillary action. Yes. What does it mean, capillarity? You have studied or not in physics?
It's a rise or fall of liquid level in capillary.
Yes, good. Rise or fall of the liquid. Yes, answer is correct. Rise or fall of in capillary. Okay. Now see, whenever you are going to consider this point, whenever you are going to consider this point, see whatever the capillary action it is there, that is good in case of the synthetic fiber. Capillaries rise. There's one more method it is that is called a wicking behavior. Wicking means, now suppose this is a water container, it is there. In that, we have kept a polyester fiber fabric. So in this case, whatever the capillary rise it is there, that is good in case of the polyester fabric. Suppose side by side one cotton fabric it is there. So cotton will get wet out, but whatever the capillary rise it is there, that is a poor. Means here, suppose if you are keeping for 1 hour, after 1 hour, if you notice, in case of the polyester, there is a tremendous rise it is there as compared to the our cellulosic fiber fabric or the porous fiber structure it is there. Because here, whatever the thing which is happening, that is because of the absorption. And here, in case of the polyester, whatever the thing which is happening, that is because of the adsorption. And because of this capillary rise method or the because of this wicking behavior only, whatever the synthetic fiber fabrics are there, they are more popular in a sportswear. Now, if you see whatever the tracksuits are there or the clothing which are using for the gym, see they are made up of polyester. They are not made up of cotton or cellulosic fiber fabric. Now, why they are made up of synthetic fiber fabric? Because of this reason only. See, if you see, whenever there is a perspiration, it is there. Suppose if you are using the cellulosic fiber clothing during this activity and during the gym or workout. See, if you are using the cellulosic fiber fabric, what will happen? Whatever the perspiration or the sweat it is there, it will get absorbed by the fiber, cellulosic fiber fabric. And they got the tendency to hold the moisture or the water. So because of which, what will happen? Whatever the fabric it is there, the fabric will stick to our body. And that is called a clinging. Clinging. C-L-I-N-G-I-N-G. Clinging. Clinging means sticking to the body. Because of which you will feel uncomfortable. You can easily notice whenever the rainy season it is there. And if we get completely wet out, what will happen? Because of the completely wet out, we will feel uncomfortable because of the clinging of the garments to the body. But instead of that, if you are using the cellulosic fiber fabric during the workout, and because of this capillary action only, whatever the perspiration it is there, suppose this is our fabric, it is there, and there is a perspiration it is there. So this perspiration, because of the wicking behavior, it will come onto the surface of the fabric and then it will go to the atmosphere. That's why whatever our uh, fabric which you are using for the workout, that is a polyester, which you are using it is there, it will get easily dry out. So there's no any wetting of the clinging of the fabric it is there. So that is because of the good capillarity, or we can say the because of the good wicking behavior of the fiber, whatever the fabric it is there, it get dry out. That's why such type of the fabrics are more popular in a sportswear. Though see, now in this case, synthetic fiber, they got the poor porosity, but still we are using these fibers. In case of the cellulosic fibers also, we got a good porosity, still we are using the fiber. That's why it is a desirable, it is there. Means even if it is there, that is well and good. Now in case of the synthetic fiber also, see we can increase this property, porosity, by doing the modification during the spinning stage, that we can manufacture the hydrophilic polyester, we can manufacture a hydrophilic nylon, we can manufacture a hydrophilic acrylic fiber. So that what the moisture level it is there, that we can increase. See, in case of the polyester, what the moisture it is there, that is in the range of 0.4. It is around 0.4% it is there. But if you are manufacturing the hydrophilic polyester, that moisture again level can go up to 6 to 8% also, just like a cotton, we can make it. So that way also we can do the modification, or by means of the chemical modification where we can carry out the surface roughening of the fiber, or we have to create the micro cracks onto the surface of the fiber, because of which we are going to get the moisture get entrapped in the fiber. And because of the entrapment of the moisture in the fiber, we can have the capillarity, or we can have the increase into the moisture regain property of the fiber. Next, related to the luster of the fiber. Now again, luster, we can have it in a few fibers, or there will not be any few fibers. So regarding the luster again, so natural luster enhances the value of the textile fiber, especially in a natural fibers. So the natural luster of the silk gave us it a long time distinct advantage over the other textile fiber. Now we know that why silk is much popular over there, because of its natural luster. Now that point we are going to study. See, if you see the silk structure cross section, it is a trilobal, triangular shape it is there. And there's a surface roughness is there. That's why whenever the light is falling over here, this light is reflected in a multiple direction. And we are going to get more of the luster over there. That's the case with the silk fiber it is there. So since the introduction of the viscose, however, is extremely high and almost metallic luster, consumer taste has gone a little in the opposite direction, and many fabric produced today are purposely delustered in order to give the desired matte finish. Now, when this particularly viscose rayon came in the market, if you see the appearance of the viscose rayon, it is highly lustrous. Luster just like a silk, we are going to get it. Metallic luxury, which is written over there, means if you see the silk, it's more glazy and the lustrous fiber. Sorry, when we see the viscose yarn, we'll get more of this, particularly the metallic luster, just like a luster which you are going to get in a steel or the likewise thing. So sometimes see what happens, see, always to have the luster in a garment is not the desired one. Hmm, it will give us a unpleasant feel. Suppose now when you are using this, particularly the shirt, trouser or the dress material, which is too much shiny, are you going to use daily such type of the clothings? No, at least I will not. Because it will not give the good feel to the user also, to the uh, person, those who are surrounding also. So what the solution for this? So there is a solution in there that is called a delustering. So whatever the viscose fabric, viscose yarn it is there, or the even same case we got the synthetic fibers, just like a polyester it is there, nylon is there. See, these fibers also got too much luster. Now to suppress this luster in case of the synthetic fibers, what we are doing, we are purposely adding delustering agent. See, in case of the synthetic fibers, what we are doing, we are purposely adding the delustering agent, just like a TiO2, titanium dioxide. So when you are adding the titanium dioxide, what are the reflection of the light it is there, that is a minimize, and we are going to get a deluster polymer. So such type of the polyester is nowadays manufactured by the industry. And very rarely, depending upon customer requirement, they are manufacturing the bright polyester. Otherwise, nowadays, in a market, whatever the polyester which you are going to get, that polyester we are going to get deluster. And this, see what are the intensity of the luster it is there, this we can modify also by changing the percentage of the titanium dioxide. See, during the melt spinning is going on. During this melt spinning, what we are doing, we are adding the slurry of the titanium dioxide, so that whatever the polyester which you are going to get, that polyester will be deluster polyester, we will get it. Therefore, it is evident that luster under certain conditions and for the certain purposes may enhance the value of the fiber. Just like a silk fiber garments are there, no doubt that ethnic wear and all these things, such type of the garments are more popular, where we can use such type of the fibers, no doubt. But in few cases, too much brightness may be the source of aversion to the user, and hence it has to be delustered to required degree of the luster by the delustering process. Now, even see during the processing also, if you don't want to have too much luster in a garment, we are carrying out one operation that is called a decatizing. So when you are carrying out the decatizing, during this process, whatever the polyester it is there, the polyester or whatever the fabric it is there, there is a loss into the uh, luster of the fabric it is there. So that also we can do. Then next, regarding the durability of the fiber. So the textile fiber should withstand the processing treatment and should not be easily susceptible to physical, chemical, and biological attack. Now, physical means, see, whenever we are using the garments, see, we are bending it, we are pulling it, we are stitching it, we are compressing it. So all these, whatever the activity are there, physically it is there. So this is nothing but the various physical treatments. Chemical means see, during the processing we are using so many chemicals, or after the fabrics are ready, see, even it is coming in contact with the various type of the chemicals. See, whenever the perspiration it is there, we got this acidic perspiration as well as we got the alkaline perspiration. Depending upon human body, pH will change. So these conditions, when you are carrying out the washing of the garments, we are going to get the alkaline pH over there. So just a minute. So whatever the processing it is there, or even see, when we are using the white garment, we are carrying out the bleaching also. For bleaching, we are using various type of the oxidizing agent, just like a peroxide is there, means hydrogen peroxide, sodium hypochlorite. This type of the chemicals we are using, so that will cause damage to the fiber also. So that is nothing but the chemical attack it is there, biological or the bacteriological. So whatever the various type of the bacteria which are present in atmosphere it is there, or whenever you are storing, or if any food material it is there, if it is remaining as it is, from this also bacteria will be there. Whenever we are using the garment it is there, whatever the sweat is released it is there, along with the sweat also there will be the bacteria are there. So bacteria are everywhere it is there. So from this also there will be the attack will be there. Miss, now instead of using the term bacteriological, I will use the term microorganisms. Means in that fungus is there, algae it is there, viruses are there, and the bacteria are there. So they all are also attacking onto the fiber, hmm, which may result the damage or the decomposition of the fabric. Now, see, just to tell you, see, right now the whatever the atmosphere it is there. Current atmosphere is a it is a wet. So there is a more chances of the development of the bacteria onto the garment. And in such cases, suppose if you are keeping our woolen and the silk garment as it is, what will happen? There is a tremendous damage to the fiber it is there. Because whatever the wool and the silk, that is a proteinous in nature, and protein is a food. So fiber will get more easily attacked. Second, if you consider the cellulosic fiber fabric, hmm, that is again carbon, hydrogen, oxygen, carbohydrates are there. So secondly, they will get attacked. And lastly, the synthetic fiber will get attacked. So whenever we are using such type of the garment, wool, silk or the cellulosic, or if you are keeping as it is, see, it is always advisable to change the position of the garments. So that whatever, if the garments are remaining in that particular environment or the cover, there is a warm and humid atmospheric conditions are developing over there, which will cause development of the bacteria over there. And because of the development of the bacteria, there is a strength loss is there in a fabric, or sometimes we are going to get the patches in a garments. Hmm. So likewise, we are going to face the problem. If you want to try to experiment, you can do one experiment. Hmm. You can take the cotton fabric, take cotton or the wool fabric, dip it in a water, dip it in a water and remove it and keep as it is for a couple of days. After 2 to 3 days, you just take the smell of the fabric. You will get the foul smell. Now, why you will get the foul smell? Because there is a bacteria attack is starting onto the fabric. Hmm. So if you want to try, you can check it in your home also, hmm, and tell me your response next lecture. Hmm. I think it's easy to try to you. Next, the durability of the clothing to average wear and the tear depends somewhat more on to the elasticity, flexibility, resistance of the fiber or the fabric, rather than the absolute strength of the either fiber or the fabric. Now, related to the physical things. So, whatever this durability it is there, it depends on more on to the elasticity, means how much elastic nature is there in a fabric, how much flexible it is there, and its resistance to the other agencies, just like a chemical, bacteria, or the physical things. Based on this, the durability of the garment is dependent. Now, the term durability means how long lasts our garment. Now we are talking regarding this. Hmm? So if the fabric possesses these three properties, its garment will absorb or the counter more readily stresses and the strain during the wear. Hmm? So wool garments owe much of their durability to the elasticity, resilience, and the flexibility, because wool is elastic in nature. That's why when you are stitching it in there, again it will come back to their original position. It got a good resilience, as I told that when you are pressing it in there, again it will come back to its original position. Wool garments are flexible to wear. A simple example you can take when you are using the sweater. Hmm? So it is a flexible, it is a elastic, it is a resilience. Hmm? So strength combined with these properties provide the excellent durability. That's why nylon and the polyester fiber fabric seems to last forever. Now, if you see the case with the synthetic fiber fabric, they got the good physical properties. They got the good chemical properties. During the practical only, I shown you that whatever the nylon material, it got a poor resistance toward the acid, but it got a good resistance toward the alkalis. Polyester, it got a good resistance toward the acids. Acrylic also it got a good resistance toward the majority of the acids and the alkali. So that's why whatever the synthetic fiber fabrics are there, they are more durable as compared to the natural fibers. Even whatever the synthetic fiber fabric, their strength, if you check, it's more or almost we can say the 1.5 to 2 times higher than the natural fibers. In few cases, we are going to get that strength also. Regarding the bacterial attack, these fibers will not get easily attacked. It takes hundreds of years to degrade the synthetic fiber fabric, whereas whatever our natural fiber, they will get easily degraded. Because of all these reasons only, whatever the synthetic fiber fabrics are there or the garments are there, they are more durable as compared to the natural fibers. So again, if you see in that natural fiber, whatever the cellulosic fiber fabric, they got the good as compared to the proteinous fiber again. Proteinous fibers are weak in nature. That's why we need to take more care as per the proteinous fiber garments are concerned. So that is regarding the durability. Okay. Now we'll see one video related to the properties of the fiber. Just now, whatever the various properties which are studied, based on this, there's one video, it is there. We'll see this.
Hey guys, this is Abhimanyu Kaushik and welcome to Text Connect, a learning center for textile. I will be discussing with you the essential and the desirable properties of a textile fiber. When you go through the video, you will come across new concepts and terms, but don't worry, we will have individual videos made on them too. So hope you like the video and let's begin. So I believe that before starting or building anything, we should be well aware of the properties of the very basic thing involved. And in our case, that is a textile fiber. Also, if you guys have watched our video on spinning process explanation, you might have got an idea that we spin fibers together to form a yarn. Let's begin with the very first essential property, which is length. Now, fibers should have considerably long length with reference to its diameter, because longer fibers will result in a and that would eventually have lesser slippage of the fibers, and it will give us a better strength. If the fibers are small, it wouldn't be possible for us to build a stronger yarn, as the small fibers will constantly protrude out. Now, a key point to be noticed is that the length to the breadth ratio of any textile fiber is greater than 1000:1. Coming down to the second property, that is strength. By strength, I mean it can be tensile strength, bending strength, or a bursting strength. Now, this strength is derived by maximum load that the fiber supports before breaking off, which is actually, in simple terms, its load bearing capacity. As this strength is applied along the axis of the fiber, it is designated as tensile strength. तो ये measure होता है in terms of stress applied per unit cross section area. That is what we call as tenacity. And it is expressed in the terms of grams per denier or grams per text unit. The third one in the list is uniformity, which is not very difficult to understand as the name itself makes it very clear that we are talking about evenness of the fiber in the length and the diameter. If fibers possess this quality, they can produce quite even yarns, and even yarns ultimately result in better strength. None of the natural fibers have same length and diameter in a same lot. And on the other hand, man-made fibers are uniform because they are cut to the exact same length when they are spun and drawn. The fourth and the last amongst essential properties is spinnability. It is the ability of the fiber to be spun together to form a yarn. This has two sub-properties which actually define the extent of spinnability. And these are flexibility and cohesiveness. So the fiber should be pliable. By pliable, I mean that it should be flexible enough to wrap around one another during spinning process. Now talking about cohesiveness, it is actually the property of a fiber to cling or to stick on with one another. To avoid the slipping of fibers, there should be a certain degree of friction between them, जिससे कि fibers slip ना हो. For example, wool fiber has an edgy surface. The edge on the surface of the fiber are called scales that prevent the fiber from slipping. We have individual videos made on these properties of each fiber. Don't worry. Okay, so let us now discuss the desirable properties. And the very first desirable property is fineness, that is fineness of a fiber. It is the relative measure of the thickness or the diameter of the fiber. So if the fibers are fine, there will be more number of fibers accumulated in a cross section, which will result in more fiber to fiber friction, and it would eventually give us greater strength in the yarn formed. The opposite of a fine fiber is coarse fiber. We cannot measure fineness just by measuring the diameter. Why? Because it is not uniform throughout its length. So what do we do is, we measure the fineness in terms of linear tensity. Coming down to resilience. Now imagine that you have compressed a spring. After you leave it, it comes to its original shape. This is what resilience actually is. It's the tendency of that fiber to regain its original shape when it is deformed. Now why is this desirable? Because it gives us recovery from creasing and wrinkling. Capillarity or porosity. It tells us about the tendency of the fiber to absorb moisture, liquid lubricants, dyes, oils, and etc. The natural and man-made fibers differ greatly in porosity, as natural fibers have higher porosity than compared to the synthetic ones. Coming down to luster, it is the desirable property because it defines the shine of the fabric, which is visually quite appealing. We get luster due to the amount of light reflected by the fiber surface. Silk has been one of the most distinct and special fibers because of its luster. But sometimes too much of a luster is not very good. So to reduce that, we follow delustering process. Now coming down to the last property in our discussion today, which is durability. A textile fiber should withstand processing treatments and should not be easily susceptible to the chemical or the bacteriological attacks. It should have good elasticity, flexibility, and resistance. Now, if these three properties are combined with absolute strength, this will provide us an excellent durability. For example, fabrics made up of nylon and polyester. So this was it from my side.
Okay, so I think now the concept related to the essential properties and the desirable properties is clear to you. Now, quickly we'll move to the next point. That is nothing but the concept of the crystalline region, amorphous region, and the mesomorphous region it is there. So before moving to this point, that is the crystalline region, amorphous region, and the mesomorphous region, first we must have to understand there's one term that is called as orientation, and based on this only, whatever these three distinct whatever the regions which are there, that crystalline region, amorphous region, and the mesomorphous region, we are going to get it over there. So what does it mean? That is orientation. So orientation of the polymer should be capable of being the oriented. Now orientation means it is the alignment of the polymeric chains parallel to the fiber axis. Hmm? Now whenever this alignment is going to take place, it is there. See, not necessarily that all whatever the polymeric chains are there, they will get aligned parallel to the fiber axis. Suppose this is a fiber, it is there. Hmm? Now, our requirement that whatever the polymer chains are there, they must get aligned, everything parallel to the fiber axis. But instead of that, see, some polymeric chains will get aligned parallel to the fiber axis and some will not. And there will be the random arrangement will be there. So whatever this alignment it is there, this alignment is more in few fibers. This alignment is less in few fibers. Or whatever this thing it is there, that is in between also we can have means more or same parallel alignment will be there. So the polymers or the polymeric chains are aligned into more or less parallel order in the direction of the longitudinal axis of the fiber axis. That is nothing but the orientation it is there. And based on this orientation, we got these various regions in a fiber. So orientation of the polymers in a polymeric system of the fiber consists in a two forms. And these two forms of polymer orientations are amorphous region, where whatever this alignment it is there, this alignment is a random it is there, means it is not parallel to the fiber axis. And crystalline region is a region where whatever this alignment it is there, this alignment is a highly ordered or the highly oriented it is there. Now we will see what the difference between these two. And based on this, I will tell you the one more point that is nothing but a mesomorphous region it is there. So what is the orientation? Orientation is nothing but alignment of the polymeric chain parallel to the fiber axis it is there. That is nothing but the orientation. If the more is the alignment parallel to the fiber axis, we are going to get a crystalline region. And if there's a random arrangement of the polymeric chain to the fiber axis, that is called as amorphous region. So within the polymer fiber system, the extent area of the crystalline and the amorphous region is varies. See, there is no any fix that will get the now the amorphous region, now the crystalline region. No, that extent is going to change. It is there, or even the whatever the area it is there, that area is also changing. So proportion of the amorphous net and the crystalline it is also very considerably. Even we got the same type of the fiber. For example, suppose if you got the cellulosic fibers, if you got the proteinous fiber, if you got the synthetic fiber, even that also, whatever this proportionality there, the proportion of the crystallinity and the amorphous region is that is going to change. Even within the fiber also, that is going to change. So we will not get any fix in case of the natural fiber. That's we are going to get a little bit variation it is there, but it got a certain range is there. The extent of the area of the amorphousness and the crystallinity can be maintained during the production of the man-made fiber. But in case of the man-made fiber, this we can control. Whatever this extent it is there, this extent we can control it is there. So it is not known how to orient the polymer occurs during the growth in a natural fiber. Now, in case of the natural fibers, see, at these things we are going to get the naturality there. We don't know how these polymeric chains they get orient themselves. Means in few cases we are going to get more of the crystalline region. In few cases we are going to get the lesser crystalline region. So that region is changing over there. So we cannot say that now we are going to get the crystalline region means everywhere crystalline region will get or that much portion in the crystalline region it is there. No, because as things is going on naturally, it is there growing. So we are going to get the variation over there. But in case of the man-made fiber, there's one operation it is there that is called a drawing. See, after the manufacturing is over, we are carrying out the drawing operation. So whenever we are carrying out the drawing operation, during this drawing operation, we are carrying out the stretching it is there. And after the stretching is over, or during the stretching operation, whatever the polymeric chains which are present in a fiber it is there, this polymer chains get aligned parallel to the fiber axis. So in synthetic fiber, this orientation we can control. See, while studying the synthetic fiber, I'll tell you. But in case of the synthetic fiber, see, even within a polyester, we can have the low oriented fiber, we can have the medium oriented, we can have the highly oriented, we can have the fully drawn yarn, or we can have the highly oriented. Means likewise, depending upon our requirement, we can change it is there. We can have the partially oriented. So likewise, 4 to 5 different type of the orientations we oriented yarns or the fiber we can manufacture in case of the synthetic fiber. Because these things are in our hand, we can control it is there. But whereas in case of the natural fiber, we cannot control this orientation. In case of the synthetic fiber, depending upon how much draw ratio is required, at what speed we are going to manufacture, we can have the low oriented, medium oriented, partially oriented, highly oriented, or the fully drawn yarn. But which is not possible in case of the natural fiber it is there. So with the man-made fiber, the operation called drawing, which stresses the extruded or the coagulated filaments, means the filament which we got after the manufacturing, causes the polymer to orient themselves longitudinally into the more or less parallel order, resulting in a formation of the crystalline region, which greatly increase the strength of the fiber. Now, when you are carrying out this particular operation, means the drawing operation, there is a tremendous increase into the strength of the fiber. Now, what does it indicate? See, as we are carrying out the stitching operation, there will be increase into the crystalline region, and as the crystalline region is increasing, there is an increase into the strength. Means, what is the crystalline region it is there? The crystalline region is mainly responsible for the strength of the fiber. Clear the points? So next see. So what the difference between these two? So amorphous polymer orientation and the crystalline polymer. So amorphous orientation of the polymer system of any fiber is called as amorphous region. Crystalline orientation of the polymer within the polymer system of any fiber is called as crystalline region. So polymers are oriented or aligned at a random fashion in amorphous region, shows no particular order of the arrangement. In a crystalline region, what the polymers are that they are oriented or aligned longitudinally into more or less parallel order. Now the random orientation of the polymer are further apart, which results in, so what we are going to get? Formation of less effective interpolymer forces of the attraction. Here we are going to get formation of the more effective interpolymer forces of attraction. Next, permits easier entry of the water dye molecules as well as the ions or the radicals of the degrading agent, whereas restrict the entry of the water and the dye molecules as well as the molecules, ions or radicals of the degrading agents. Means amorphous region is mainly responsible for absorption of the dye and the water, where the crystalline region is mainly responsible for the mechanical properties of the strength of the fiber. Now allow the polymer to be readily displaced when the force is subjected to the stress and strain during the wear. Means this, what are the amorphous region it is there? It is a weak region. It got a poor mechanical property, whereas do not allow the polymer to be displaced when the fiber is subjected to the stress or the strain during the wear. Means crystalline region got the good strengths, and because of this good strength, whenever we are using it there, whatever the stress strain which are applying during the use, it is there, that stress strain will be beared by this crystalline region. So crystalline region is a region where molecules are regularly or closely packed. In this constitute of the element, molecules have the fixed position in a space relative to each other. This accounts for the solid structure or the rigidity of the fiber. Crystalline regions give the stiffness to the fiber. It gives the durability to the fiber structure. It gives the strength to the fiber. Means if you see whatever the crystalline region it is there, it is mainly responsible for the mechanical properties. If any fibers having the high crystalline region than that of the fiber is stronger, more durable, less easily degraded by the chemicals, less plastic, resist being distorted, less absorbent, as well as the pliable and the stiffer in handle. And when you are talking regarding the amorphous region, so it is the region of the fiber structure where molecule chains are randomly or loosely bonded. They gives a flexibility of the extension of the fiber. This region is responsible for the absorption of the moisture and the dye. And any fiber having the higher amorphous region, then that fiber is more absorbent and can be easily dyed, more pliable, softer in handle, weaker, has less durability, plasticity, and can be easily distorted easily by the degrading agent, just like a chemicals over there. So that the amorphous region it is there. Now if you see this, now one more point which is left, that is nothing but the mesomorphous region it is there. So as I told you, you can see over here. So crystalline region is the region where the polymeric chains are compactly arranged, and amorphous region is the region where polymeric chains are randomly arranged. So this is a crystalline region, this is a crystalline region, this is a amorphous region, this is amorphous. Then where is this mesomorphous region? So mesomorphous region is the region between the crystalline and the amorphous region. So you can check over here. This is a crystalline region, this is the amorphous region. So whatever this region it is there, whatever this region it is there, this region, this region, this region is nothing but the mesomorphous region. So mesomorphous region is nothing but the region between amorphous and the crystalline region it is there. So see, in case of all fibers, we will not get the mesomorphous region. See, all fibers are not two phase. So this is also called a phases. Crystalline phase, amorphous phase, it is there. Some fibers got a three phase also. Not the electricity. Phases means crystalline and the amorphous and the mesomorphous. So all fibers are not two phase material. Some of the fibers are three phase material it is there. Just like a cotton, in which we are going to get the crystalline region, we are going to get the amorphous region also, and we are going to get the mesomorphous region also it is there. Got this point? Crystalline region, amorphous region, and the mesomorphous region. So if you see the properties of the more amorphous fiber, more absorbent, weaker, less durable, more easily degraded by chemicals, we can easily carry out the dyeing, more pliable, softer handle, plastic, more easily distorted. Crystalline region, less absorbent, more stronger, more durable, less easily degraded by the chemicals and the dyes. They are less pliable, stiffer in handle, less plastic, and resist being distorted it is there. And this is the crystalline region of the sum of the fibers. If you see the crystallinity of the cotton fiber, it is a 63 to 67%, natural rubber 28 to 30, viscose rayon 33 to 37, polynogic rayon 39 to 47, lyocell 55, wool 40, silk 60, polyester around 58 to 60, nylon 6 got 50 to 55, nylon 66 55 to 60, acrylic around 50 to 60 it is there, LDP 60 to 80, HDP 80 to 98, polypropylene around 55 to 60. So likewise, this is a crystalline region, and amorphous region is nothing but 100 minus this. We will get the amorphous region. Now, as I told that, at this particularly the fiber, even if you got the same class, just like a cellulosic one, proteinous one, synthetic fiber. Again, you will find that there is a variation. For example, if you see the crystallinity of cotton, that is a 63 to 67%. Viscose yarn, exactly opposite, that is 33 to 37%. Means viscose yarn is less crystalline as compared to the cotton. That's why if you see the strength of the viscose yarn is lesser than the cotton. But if you see the absorption, dyeing behavior, moisture regain of the viscose yarn, it is higher than the cotton because crystallinity is changing. Similar case with the polynogic. If you compare the viscose yarn, polynogic rayon, cotton, and if you are performing the dyeing or the coloration, you'll find that viscose yarn will get dyed darker as compared to the polynogic rayon. Polynogic rayon will get dyed darker as compared to the cotton. Because crystallinity changing. Higher is the crystalline region, lesser will be the dyeability. That point you have to take into consideration whenever you are considering fibers from the same class. Don't mix the fiber of the cellulosic with the synthetic and the protein. That is going to change. So clear these points? Yes, clear?
Yes, sir.
Okay.
Yes, sir.